Welcome to Beyond the System with Dave and Josh.
Hey, welcome back, everybody, to Beyond the System. And today we're going to take a very deep dive into the heart of the refrigeration system, the compressor, right, Josh?
Absolutely, Dave. One of the most critical components in the system, the heart of the system, you may say. Something that if it doesn't get appreciated, it's going to let you know.
Absolutely, 100%. And the good news about a compressor, though, is that it's one of the components that can be maintained, and if maintained, may outlast your plant itself. Is that correct?
May outlast your plant and your employment.
That's right. So before we get going, let's start simple, Josh. Before we get into this deep dive, what role does a compressor play?
So the compressor is basically the heart of the system. It takes low pressure vapor off of the evaporator. It increases the pressure, it sends it to the condenser. And the reason why it's so critical is that we need the pressure increased to increase the temperature so that we can reject the heat that we're absorbing in the evaporator. Aside from increasing the pressure, it also keeps the flow of the refrigerant moving through the system from the high side to the low side, and basically creates our continuous loop through the refrigeration cycle.
Okay, and really there's different types. Like there's your reciprocating, your screw. What other sort of compressors do we have that we
Yeah,
would look
there's
at in a refrigeration system?
Yeah, I mean, on some of the smaller, maybe mechanical dehumidifiers, you might get what they call a scroll compressor. On some of the large air conditioning applications, you would see a centrifugal compressor. In our business, our industry, HVAC, refrigeration, you're going to see a lot of small HVAC compressors, be either the scroll or the reciprocating machine, but they would be a hermetic machine, meaning they're mechanically sealed and they typically can't be serviced. That's why if your dehumidifier compressor fails, you typically see, mechanics coming in and re-enringing the compressor with the new one. There's really no saving those. But on the more industrial application, you're going to probably see big screw compressors just based on the sheer volume of work they can do in a smaller footprint than a reciprocating machine. And then in ice rinks, you're going to see a variety of screws and recips, more of the mini screw type compressor or the reciprocating compressor. I would say probably majority of ice rinks, you're going to see reciprocating machines.
Makes sense. And they're like essentially just like a pump, right? I mean, you're talking about earlier about high pressure and increasing pressures and heat, et cetera. But really, they're just pumping the refrigerant throughout the refrigerant cycle, correct?
Yeah, they're pumping refrigerant vapor. One thing that has to be known, you cannot compress liquid. So that's why we have heat exchangers with vessels above them. Those vessels, they allow for separation from liquid and vapor, and they provide the protection to the compressor. Without it, you have to critically control your refrigerant flow through, say, a direct expansion type loop, which can put the compressor at risk, especially bigger compressors. They require superheat to protect them. The superheat ensures there's no liquid left in the vapor stream. And when we're talking about ice rink application or industrial refrigeration, often the band is so tight. We don't carry a lot of superheat over to the compressor, often zero, and we need those vessels there to protect from any liquid getting into the compressor. So, it's basically, as you mentioned, a pump for the system in the most simple terms, but very critical.
Yeah, it's a bit different than some of the other components in the system where, like, let's say, for example, like a condenser or heat exchanger, as it's starting to lose efficiency or as maybe it just works harder. But the compressor, that's not quite the case, is it?
Well, I mean, I would say that depending on how well maintained the compressor is, it will always have a limit to how hard it can work. I think from a working harder perspective, it means it's working longer. It's going to take longer to do its job because, the clearances inside these compressors around either the piston rings or, say, the lobes of a screw, they're so small that when they start to wear, you can start to lose efficiency pretty quickly. So you want to keep an eye on your compressor at all times.
Yeah, okay, interesting. And it's what's interesting about compressors, it sort of follows the car industry with the main manufacturers from Japan, the United States, Italy. I believe there's some Nordic countries that produce some. So
Yep,
it's very, very
Germany.
similar. Germany, yep, same thing. So I always find that interesting industrial, like they come from the same place.
Yeah,
And
precision
yeah, similar
machines.
car. Yeah. So, okay, so let's dive into the inspection. And this is, rather a general deep dive. If you want to say, we'll get into future episodes where we look at some of the, maybe specific models, et cetera. But, let's say, for example, I'm heading into an engine room and I'm focused now on compressors and I want to inspect. What does that look like?
Yeah, I mean, and just so everybody knows, carrying the IMR mindset, inspect, maintain, replace, I'd say we're moving into the first phase as well in this discussion, which would be inspection. And one thing that you want to make sure you have on hand is a good logbook, a good place to store records, and do very consistent readings. So, on a reciprocating compressor, on any compressor, you're going to want to know your high pressure, your oil pressure, and your low pressure, and document them, because those may lead you to other challenges with your system. It may not always be a compressor issue, but those recordings will help get you there. Often they may have discharge temperature. Sometimes they do, sometimes they don't. Oil temperature is also another important number, usually not available on a smaller machine, but on the smaller reciprocating compressors, you'll usually have your cooling temperature. So you're going to want to make sure you get your jacket cooling temperature. And that's if it's an ammonia compressor. The odd R22 older system with reciprocating machines out there in the world will also have jacket cooling. But typically on the Freon systems, the temperature under the heads don't get high enough to require it. So your jacket cooling temperature, your high pressure, your oil pressure, and your low pressure are typically all the things you're going to want to record. And then, further than just what you're recording, I always liked operators or engineers or whomever is the guardian of the equipment to document the run hours as well, because I like to set service intervals off of run hours. I always carried a seasonal service interval, and then I always carried a run hour service interval. So if you didn't hit the run hours, but you were down for 4 months in the summer, well, cheap insurance, let's change the oil. So from an inspection perspective, your pressures, your temperatures, your run hours are all very critical. There's also some visual things that you can do while you're doing your inspection. They're all driven by motors. It might be belt driven, it might be direct driven. It could be close coupled, like on a screw compressor. Often you see the coupled through a tunnel and you won't be able to see what's in the tunnel. But visually, you can tell if there's oil leaking, for example, because if they're open drive machines, they have a shaft seal. If it's leaking oil, then I want to make sure that I keep an eye on that. On a reciprocating and screw compressor, there is a tolerance for leakage. Just because there's some leaking doesn't mean that it's a problem. But if it's leaking out of the shaft and not through the drip tube into the collection bottle, that's a problem that needs to be addressed. So when I'm doing inspections, I always want to check the shaft seal, see if it's coming out the shaft. I want to check the oil bottle to see how much it's filling up. And then so in the logbook under your inspection section, note how much that bottle is filling up, because eventually you're going to walk in and it'll be overflowing. And is it overflowing in one day, or is it overflowing in 6 months? And so, keeping an eye on those things, obviously cleanliness around the machine will help you identify these things. If you have a very disorganized, dirty room, oil might be accumulating on the floor or maybe under a box that you haven't moved, and you won't notice it until it gets worse. So, pay attention to oil leaks, monitor all your pressures and temperatures. And then also your belts or your couplings. If it's a direct drive, often there'll be a metal coupling. Not a lot is going to happen to those, but if you see a piece of thin metal broken off near the coupling, it could be one of the discs broke. If you have a direct couple with a bit of sort of a rubber insert, if you want to say, often they're very hard. If you start to see shavings of that around the tunnel or around the compressor, then it could be an issue. And on a belt driven, if you see belts flapping all over the place, maybe they've hit end of life. maybe one belt's broken. If you're using your reciprocating compressor and you're unloading it and it's belt driven, often at different stages, your belts will react differently, but under full load, they should be tight. It should be quiet, down to motor noise, and then also monitor your motor. Motors typically require grease for the bearings. You're going to want to record when that's happening. And one very critical thing for greasing bearings, make sure you stay consistent with the type of grease that you use. You don't want to be putting a variety of grease. So if you have, a grease gun with a tube of grease in it from your Zamboni, it may not be the right application for your motor. So make sure you have dedicated tools, make sure the area is clean, make sure you record all of that information as I suggested, and then make sure that none of your cooling jackets are leaking. So often we'll have a glycol cooling system on the heads on a reciprocating machine, and usually it's pink, maybe it's blue, depending on what type of application you're using, but usually pink. So if you see pink liquid leaking from anywhere, advise your service provider that, hey, I have a leak here or there, and get it repaired and get it maintained. If you maintain all of those things consistently, record that information consistently, I think you're in pretty good shape, Dave.
Yeah. So that's a lot of things you record. I mean, obviously it's going to help if the service guy comes in, save them a lot of time to diagnose your issue properly. A lot of visual you talked about. What about hearing? Like, sometimes I go into a room and I'm listening to the compressor and somebody who's really experienced can say, oh, I can tell something's wrong with that. I mean, what are you listening for if that's going to be a way of inspecting things?
Yeah, I mean, really, I can't say that you're going to be listening for something very specific. I think what you're going to be listening for is something abnormal, something that you don't typically hear. If you are the type of operator that shuts everything off every time you go in the room, you're kind of missing out on this. I would suggest always wearing hearing protection when the system's in operation, but you almost get a feel for the vibrations, for the sound, for everything that's happening in the room. And that day that you come in and something is not right, likely the people that are doing these inspections consistently, they're going to pick up on it just based on the sound. It could be a rattle. It could be, if a belt broke off, you might smell it. You might smell the rubber burning. You might hear the belts flapping differently. I've been on service calls where a motor's come loose, and it's moved forward and all the belts are loose. So, hearing is a great sense to be using, your sight, your sound, and even your smell often. If you had a small ammonia leak, you're going to smell it. So, I'd be keeping my eye out for those as well. But yeah, I would say get time in your room. Get time when there's one machine running, get time when there's multiple machines running, and get accustomed to those sounds. And before you know it, you'll be that person that recognizes the abnormal.
Okay, great. Perfect. So yeah, I mean, again, it's really difficult, I guess, to talk about like daily, weekly, monthly, quarterly, yearly type of things with such a broad topic on compressor. But really, if anyone is listening to this right now, it's very easy to find this. I mean, compressors are a lot of time, their intervals are based on hours, similar to our cars. And you can get a lot of details just simply by finding the owner's manual, and then obviously talking to your contractor as well too, to get very specific, which we're always happy to do. Regarding the maintenance side of things, it's not always it's not necessarily a yearly activity, maintenance. It is something that needs to be planned for. And maybe Josh, you could share some of your insights in regards to if you were running a plant, how would you plan for maintenance of compressors?
I mean, I think one thing to do if you own this type of equipment is educate yourself on what it needs, and maybe you need support from a contractor to help you do that. I'll be honest, I've read lots of manuals myself. They're not always 100% clear. Often there's little crumbs throughout a manual that, somebody that's not familiar with the equipment would be hard to pick up on, that their requirements and when they're required. So, obviously consulting with your contractor is a great first start. Getting to know the technician or mechanic that regularly services your plant is another good place to be. It is often needed more then, like the maintenance that's required is often needed more than the opinion of one person, depending on how you want to look at things. If you want to follow OEM, often it's going to be more stringent than the opinion of somebody, a mechanic or a technician or a salesperson. But sometimes at the same time, those guys or girls know that, hey, we can push certain things longer than others, but the OEM plan is very, very good. I mean, if you think about vehicles, if you follow the OEM plan, they often last a lot longer and they give you less headache. And really, that's what planning for your maintenance is all about. So, from a strategy perspective, often it's going to be what type of facility you have. If you have a production facility that's high demand in certain periods of time, well, you want to make sure that you schedule your maintenance when it is not in high demand, because you want it running. You don't want to worry about it when you're worried about your production. In an ice rink, if you're running all year round, the best time to do your maintenance, although a lot of people might not agree, is right in the heart of the season, when it's minus 25 outside, if you're, in a colder area, or when it's just cooler outside. It's going to take the stress off the equipment. Maybe you have 3 compressors. You probably only need 1. You don't have to worry about anything. So you have time to take it down during the season. If you're a seasonal operation, your maintenance should be scheduled during the off season. And it takes the pressure off everything. It takes the time. Now, if it was me, I would push to have my technician in as soon as I shut down, and maybe even coordinate my service when I shut down, because then it gives me time. Say, for example, it's time to schedule for an overhaul based on hours, and they open the machine and there's a critical component that's worn. And just because it hasn't broken yet doesn't mean it's not worn. We're doing maintenance, we're doing it within tolerances, and we're measuring. So like if, for example, you needed a crankshaft, in an emergency, you're probably not going to find a crankshaft. You're probably going to replace the compressor because they're not always available. But if you take it down in April and you don't need to start till October, well, now I can order a crankshaft and come in 8 weeks later and I'll finish my work. So it's always nice to get some level of maintenance inspected right at shutdown, so you can well prepare for it. But as long as you're doing it when it's convenient for your system, like I said, year-round operation, do it in the winter. Seasonal, do it in the off season, and production, do it when you're shut down. That's the main times to consider.
In maintenance, I think based compared to other components in the system, like I know that we send some of our people to some specific training, or they get some training from people that are senior within our own organization. But the compressor types are different, the brands are different. There's things that you need to know. So I think this is a type of thing where you'd want to ensure that whoever is servicing your equipment is knowledgeable on the particular brand, and make sure they have either factory training or some sort of training in place, because it's not something you really want to mess with when you're talking about specific tolerances and et cetera. Like, could you add a little bit more deep color on that, Josh?
Yeah, I completely agree. Our industry has thousands of technicians. They're all over the place. And I almost consider, when you move into industrial, we're like a spot on the spot. You could say, big spot is our industry. It's our little refrigeration industry. And we're just like a little speck in there is the industrial refrigeration industry. So, for one to assume that a technician that is not in the industry can just do the work because they are in the HVAC refrigeration industry is not something that anybody should assume. The technicians that work with us, I mean, they get days and days spent with senior technicians. When you think of overhauling a reciprocating compressor, a technician might overhaul that same compressor 10, 12 times in their career. But, you have 3 in the room, that's 36 times just for one site. Now they work on 15, 20 sites. Like, all of a sudden they've overhauled hundreds and hundreds of compressors. And, to get that knowledge and to have it really wired in, it takes time, and it just takes repetition. And, those are the guys and girls that can come in and they can hear the problems like you mentioned earlier, even though they're not on your site, because they're so used to hearing reciprocating compressors run or screw compressors that they just pick up on these little things, or they know that when they take a part out and it's worn, where can I allow tolerance if budget isn't available to change major components, and what are the critical no-go components that you can't avoid changing. Without that time, without that experience, without that mentoring and training, yeah, Dave, you're absolutely right. You could get yourself into a situation where you think you have reliable service and you don't. And, you won't know until it's going to cost you 10 times to fix it.
What kind of questions would you ask if you want to make sure that the compressors were maintained, or you want to make sure you had the budget next year to maintain the compressors?
Yeah, I mean, from an internal staff perspective, typically there's going to be enough awareness there to know when the service intervals are required, and also they should know what the history of the service has been or the maintenance has been. And, knowing all that will help you not, get called, will help you not call out for the wrong service, and having them know that it's great. Having their routine inspections being complete is great. And then, when you do have to call the contractor, questions that you should ask them is, have they done this work before and how many times? Because there are many that have one or two compressors that are around that they might service. So in their lifetime, they might overhaul 12 times, for example, if you had to get it that deep into it, where, an expert with 20 years experience has now done 400. Like, who do you want? You want the heart surgeon that's learning, or do you want the heart surgeon that's teaching the ones that are learning? That's where I like to go. So, asking specifically for the experience, asking which brands they represent is very helpful. Asking which brands they can get direct pricing from their suppliers on, because often if you're not working on equipment enough, suppliers won't sell direct, and that's a red flag right there. So if your contractor is buying their parts through a contractor, you probably want to find out who the contractor is they're buying them from.
And this is the one area, like I think we sometimes touch on aftermarket parts. I think this is the one area where you would never, or you very rarely, or be very careful in regards to getting non-OEM parts for your compressor maintenance.
Yeah, agreed. The internal components are made to spec by the manufacturers. Like you said, they're usually machined in one of 5 or 6 countries in the world, and yes, there are aftermarket parts available from, other places in the world, and the difference might just be the quality of steel. You might get piston rings or valve rings that are made in a place that doesn't have the same standards as the other. And, then all of a sudden your components are wearing out twice as fast. I mean, you might as well throw your service intervals recommended in a manual out the window at that point, because you really don't know what you got. And, the compressor being so critical to the operation, you got to really consider, like, what are you saving in the end? Is it 10%? Is it 15%? Is it, another headache that you don't need for that money? One of my favorite lines is, like, it's not your money, but it is your responsibility. And don't think for a second you're not going to get called out when, it's discovered that a choice has been made to go this route instead of the right route. And now you got to stand there and explain yourself for it. So, not saying that every aftermarket part is bad, but, when it comes to compressors, I would just stay clean away from them.
Yes, you could ask for like a packing slip or something along those lines if you have any concerns, especially if there was like a huge price discrepancy between a couple contractors. I mean, I think it is something that is something that one could do to lower their price. And
Absolutely.
you may not be aware of it.
Yeah, and I mean, to be honest, like, packing slip, yeah, may help, but usually OEM parts, they're proud of their parts. They're labeled, everything is labeled so clearly where it came from. The tape on the box will be theirs, the paper inside protecting it from corrosion will have their name all over it. I mean, it's pretty hard to duplicate all that and still save a buck trying to do it aftermarket. So yeah, I would just stay with OEM genuine parts and be done with it.
Yeah. Okay, now moving on to replacement. Now, this one here can be really tricky because, I talked to some of our really senior mechanics here, and they would have a philosophy that as long as the compressor is maintained, you could just keep going forever, type of thing, right? With some of the recips, etc. But why don't we talk a little bit about replacement, because it's not as linear as would say against other components in the system, because
Mhm.
of their maintainability especially for open drive type of compressors. Can you talk a little bit about replacement strategy, Josh?
Yeah, so I mean, I believe there's, standards out there published by ASHRAE, potentially IAR. There's a few organizations out there, and they're usually in the range of 20 to 25 years. And, definitely, like I'm a mechanic myself, I think a well-maintained machine can run for a while, but it needs to be documented. It needs to be clear. And one of the things that often gets overlooked by extending the life of the machine is really all of the stuff that's around it, the valves, the piping, the base. I've been in on a call multiple times where the base wasn't constructed well enough. And here we are, 30 years down the road, and they've got massive vibration in their compressor room, and it's just the stress of time and vibration has finally cracked the steel base. And here we are now, luckily, without an ammonia leak or a refrigerant leak, and we're just welding the base back together. And okay, then it's you start to consider, wow, like all the movement that just happened, what else did it affect? Did it affect the valves, flanges? Did something come loose in the system? It's just all those things that might not seem like a high percentage of happening, but they could. And so, when you're changing out your compressor at 20 to 25 years, maybe 30 years on a well-maintained machine, you should look at how far back do you go in the system? Is there better insulation? Is there, different piping practices that we use now? Could it be moved to a safer location or a more accessible location? A lot of factors come in. I would say that there really is no hard and defined line other than myself. I like to go with what the experts recommend. There's a reason why the recommendations are there, and they are experts. And often, it might not mean going as far as I suggested. Often it might just mean changing out the core of the machine, on a screw compressor, the package itself, nothing really happens to it over time, so swapping out the machine is not a big deal. The motors, again, usually last a long time. I would always recommend that if you're at the point in time where you're going to change a bare compressor, you should at least send your motor out for rebuild. And if it's a smaller horsepower, just replace it. Again, cheap insurance. It's one of those headaches you do not want on a weekend or on a holiday. So there's all kinds of variables, I guess you could say, Dave, around when to and when not to. But generally that 20 to 25 year mark, a well-maintained, push it to 30 maybe. That's about as far as you want to take them. Don't run them until they stop, because when they stop, they're going to cost you a lot more money. And when you do those changeouts, you're usually working that in around your overhauls as well. So I mean, the price of labor and materials is continuing to go up. So once you hit that mark, you're really resetting all your wear parts to zero, right back to full spec, best efficiency. There's no loss, there's no shaft seal wear, there's no oil pump wear, there's no bearing wear at that point. You've started over. So, at the 20 to 25 year mark, budgeting for a bare compressor change at that point, it can make a lot of sense, Dave, versus another major overhaul on a worn shaft.
Yeah, it could certainly. I mean, it's one of those things again that planning ahead, making the financial team aware, and also maybe being mindful of potential upgrades that you could get as well too, to help with performance of the plant, because it's such a key component. And there are a lot of you don't always see it quickly, but there's a lot of technology upgrades that are available now for compressors, that can be helpful for your operations, right?
Yeah, I mean, on a piston machine, yes, there are a few versions that have come out more recently that do provide more performance. One of the things that people don't often consider, and to be honest, I only picked up on recently myself when a condenser was selected that our engineering team felt like, wow, that's on the edge. And, you think, well, the thing has been running for 25, 30 years, but what has our environment done since? Are we getting higher humidity? Are we getting drier days, hotter days, colder days? Maybe there's something else to consider, on a piece of equipment that was installed 25, 30 years ago that one might not think of. Maybe they want to increase their horsepower. Maybe they can't, based on their plant rating, but maybe they can and they could take advantage. Maybe their season 30 years ago was, October to April or October to March, and now they're running, late August for tryouts all the way into June. Maybe there's a little more jam we could give them with a different selection. So there is quite a few things to consider that could benefit them, and when a major overhaul's due, well, it's a good time to start considering.
Josh, do you have any sort of closing thoughts on the compressor, or any words of wisdom that you'd like to share with everybody?
Yeah, I mean, I think from a words of wisdom, just to recap a little, stay on a maintenance schedule. Like I mentioned earlier, either go by the hour interval or go by season. One of the things that I used to do is label panels with hours. And when I did service, you think, well, I'll write it in the logbook, it'll be fine. And then you fill up that logbook and then it's locked in a manager's office or disappears. And so tracking back to the last time something was done can often be difficult. So keep a good logs, put notes on the panel where, people can see them when things were done, and maintain consistency. And last one thing we didn't mention, because I think we'll do a whole probably episode on oil, but stay consistent with your oil as well. You don't want to be changing brands and different types. I mean, often from a brand perspective, the label on the pail, it could be the same oil with multiple names on it, but you want to stay consistent. That's kind of the lifeblood of the compressor, you might say, and the compressor being the heart of the system. You want to make sure that it's well maintained.
Okay, perfect. Yeah. So anyways, I would like to remind everybody, like and subscribe, and feel free to reach out. Josh and I are both very eager to discuss anything refrigeration related. I mean, it is our job and our passion in life. So if you do have any thoughts or comments or suggestions, we're always happy to hear from you. And until next time, Beyond the System will be waiting for you.